What China discovered on the dark side of the moon could change the fate of all humanity. A source of unlimited energy, ready-made underground cities, and resources worth trillions of dollars. And all of this is already in the hands of one country. While the whole world argues about whether it's better to fly to Mars or focus on the problems on Earth, one country is quietly and methodically taking over the most valuable object in our solar system. And it's not some distant planet. It's our own moon. China, right before our eyes, is becoming the owner of the dark side of the moon. And this means that in 10 to 15 years, the balance of power in the world could completely change. For a long time after the Apollo and Soviet lunar programs of the 1970s, humanity seemed to lose interest in the satellite of our planet. Everyone was looking farther, at Mars, the moons of Jupiter, and exoplanets. The moon seemed already studied, boring, a thing of the past. But while everyone dreamed of distant worlds, China was making very different calculations. In the early 2000s, Chinese scientists and engineers conducted a cold analysis. What is needed for a technological breakthrough? Where to find resources for energy independence? And how to get ahead of competitors while they keep dreaming? The answer was simple and brilliant. The moon, not Mars, which takes at least 9 months to reach. Not asteroids, which are almost impossible to get to, but our good old moon, just 3 days flight away. And in 2007, China launched the first spacecraft of the Chang'e program, named after the moon goddess from Chinese mythology. But this was not about romance, it was about cold calculation. Chang'e 1 created extremely detailed maps of the moon's surface and, attention, discovered traces of helium-3 in the lunar soil. Helium-3 is an isotope that can become fuel for the fusion reactors of the future. Just 2 pounds of this substance can give as much energy as 10,000 tons of coal. On Earth, it's almost non-existent. But on the moon, there are millions of tons brought by the solar wind over billions of years. What makes helium-3 so special? Unlike other types of fusion fuel, the reaction with helium-3 does not produce neutron radiation. This means safety and simplicity of reactor design. No radioactive waste, no risk of a meltdown, just clean energy in incredible amounts. According to Chinese physicists' calculations, 40 tons of helium-3 is the yearly energy demand of the entire United States. And on the moon, by the most conservative estimates, there are more than 1 million tons of this isotope. That's enough for all humanity for thousands of years. While the Americans were actively arguing about whether to shut down the shuttle program, and the Europeans and Russians were thinking about flights to distant planets, the Chinese were already planning how to become the #1 energy superpower. Chang'e 2 in 2010 took even more detailed pictures and selected landing sites. This craft was able to photograph the moon's surface with a resolution of up to 3 feet, enough to even see the footprints of American astronauts on the lunar soil and the equipment they left behind. But the main thing, it created a detailed map of helium-3 concentrations in different regions. And in 2013, something happened that many missed. Chang'e 3 made the first soft landing on the moon since 1976. For 37 years, no humans had touched the moon's surface. And then suddenly, the Chinese lunar rover U2, the Jade Rabbit, rolled across the gray dust. U2 weighed only 300 pounds, but it was packed with the most modern instruments: a panoramic camera, an infrared spectrometer, a ground-penetrating radar, an X-ray spectrometer. All this made it possible to study the moon with unprecedented detail. And most importantly, U2 worked from a radioisotope power source, which allowed it to survive the lunar night. But this was only the beginning. The real sensation happened on January 3rd, 2019. Chang'e 4 became the first spacecraft in human history to make a soft landing on the far side of the moon. The far side of the moon is not just a place we cannot see from Earth. It is a completely unique world. There are no radio noises from our planet. The geology there has remained untouched for billions of years. And there is the von Karman crater, part of the huge South Pole Aitken Basin, one of the largest structures in the solar system. This basin has a diameter of 1,500 miles and a depth of 8 miles. It was formed about 4 billion years ago by the impact of an asteroid the size of half of Great Britain. The impact was so powerful that it almost punched through the moon's crust exposing the mantle. The technical challenge was incredibly hard. From the far side of the moon, there is no direct communication with Earth. It is blocked by the moon itself. That is why, a year before the landing, the Chinese launched a special relay satellite called Queqiao, the Magpie Bridge. It hangs at the Lagrange point L2 behind the moon and provides constant communication. Queqiao is a true masterpiece of engineering. The satellite, weighing 950 pounds, is equipped with a parabolic antenna 13 feet in diameter and can transmit data at speeds up to 2 megabits per second. But most importantly, it is positioned perfectly for constant communication with both Earth and the far side of the moon. No one before the Chinese had ever done anything like this. Moreover, Queqiao is not just a relay. On board, it has a low-frequency radio telescope that can study space in ranges unavailable from Earth because of interference from our atmosphere and human-made radiation. In fact, China created the first space radio observatory to study the most distant corners of the universe. When Chang'e 4 landed in the von Karman crater and deployed the Yutu-2 rover, humanity for the first time saw what the dark side of the moon looks like up close. And what they found there made everyone rethink all plans for exploring space. The first discovery was related to the soil composition. Analysis showed that the far side contains much more rare elements than expected. The concentration of titanium, iron, and rare earth metals turned out to be many times higher than on the near side. Among the samples later brought to Earth by Chang'e 5, a new mineral was discovered, Chang'e, which contained traces of that same helium-3. Chang'e is a crystalline phosphate in whose lattice helium-3 atoms are trapped. The mineral was formed as a result of the solar wind acting on the lunar basalts over billions of years. In the 50 years since the Apollo missions, no one had discovered new minerals on the moon. The Chinese were the first to make this amazing discovery. But the truly explosive news came when Yutu-2 came across a strange shiny substance in a small crater. Social media was flooded with wild theories, from alien contact to secret military experiments. In reality, it turned out to be glass, formed by a meteorite impact. But the very fact of the find showed that the moon is full of surprises. This impact glass had a unique composition, a mixture of silicon, aluminum, and other elements melted at temperatures above 3,100 degrees Fahrenheit. Analysis showed that the impact happened relatively recently, just a few million years ago. And most importantly, the glass contained inclusions of mantle material, which confirmed theories about the deep structure of the moon. And then something happened that became a symbol of a new era in space exploration. Along with scientific instruments, Chang'e 4 delivered to the moon a small biosphere, a sealed container with seeds of cotton, potato, rapeseed, Arabidopsis, yeast, and fruit fly eggs. The biosphere was an aluminum cylinder 7 inches tall and 6 inches in diameter. Inside, it maintained a constant temperature, had a water and air supply system, and a video camera to monitor the experiment. The total weight was almost 6.5 pounds. On January 15, 2019, Chinese scientists announced the cotton seed had sprouted. For the first time in history, a plant from Earth grew on the surface of another celestial body. A tiny green sprout in the lifeless gray desert became a powerful symbol that life can exist even there. The sprout reached almost 0.5 inches in height and grew 2 cotyledon leaves. Cameras recorded every stage of growth, from the swelling of the seed to the appearance of the first true leaves. The experiment showed that plants can grow in lunar gravity, which is 6 times weaker than Earth's. The sprout lived only a few days. When the lunar night came, the temperature dropped to minus 270 degrees Fahrenheit, and the plant died. But the experiment proved that it is in principle possible to grow food on the moon, a key condition for long-term bases. However, the most important discoveries were not about biology, but about geology. Using radars, Yutu-2 scanned the lunar surface to a depth of up to 130 feet, and there it revealed an incredible picture. Under the far side of the moon, there is a network of giant underground cavities. Lava tubes formed billions of years ago when the moon was geologically active. When volcanoes erupted, lava flowed across the surface like rivers. The top layer cooled and hardened, forming a crust, while underneath the lava kept flowing, burning out tunnels. When the volcanic activity stopped, the lava drained away and the tunnels remained. On Earth, such tubes exist in Hawaii and Iceland. But because of the weak lunar gravity, they can be simply gigantic here. Some are up to 0.5 miles wide and tens of miles long. The largest of the discovered tubes is almost 1.2 miles wide and can be traced for more than 30 miles. That is bigger than the entire subway system of New York or London combined. The ceiling height in some places reaches 1,000 feet, like a 100-story skyscraper. In such a tube, you could easily fit an entire city with a population of 1 million. And now the most important thing, these lava tubes are ready-made protected shelters. Inside them, the temperature stays steady at about 63 degrees Fahrenheit. There is no radiation, no meteorites, no sharp temperature swings. These are ideal conditions for building bases. 15 years ago, the Japanese Selene orbital probe discovered more than 200 dark holes on the moon leading downward. Now it became clear, these are entrances to lava tubes, and the Chinese were the first to understand what a treasure this is. The American orbital probe, LRO, confirmed the existence of these caves using gravity measurements. Where there are cavities, gravity is weaker. The anomaly map matched exactly with the locations of the lava tube entrances. While NASA and private companies are still thinking about how to protect astronauts from radiation with heavy shields, China has already found a ready-made solution: natural bunkers created by the moon itself. The walls of these tubes are made of basalt, 100 to 165 feet thick, enough to block cosmic radiation better than any artificial shielding. Just imagine an underground city the size of several city blocks, with a constant temperature and natural protection from all the dangers of space. In such conditions, you can create a sealed atmosphere, build living modules, laboratories, even farms to grow food. Chinese engineers have already calculated the possibilities of sealing the lava tubes. It is enough to close off the entrances with special airlocks, and inside you can maintain Earth-like pressure and air composition. Thanks to the low gravity, the pressure on the walls will be 6 times less than on Earth. But the Chinese went beyond just studying. In 2020, Chang'e 5 delivered 4.5 pounds of lunar soil to Earth, the first samples in 44 years. The analysis confirmed the reserves of helium-3 on the moon are truly huge. According to Chinese scientists' estimates, 1 million tons of this isotope would be enough to supply all humanity with energy for 10,000 years. Chang'e 5 worked like a real miniature mining plant. The craft didn't just collect samples from the surface. It drilled down to a depth of 7 feet, analyzing layers of soil of different ages. The samples turned out to be the youngest lunar rocks ever brought to Earth, only 2 billion years old. Analysis showed that the concentration of helium-3 in lunar regolith is about 20 parts per billion. That may sound small, but with industrial mining, from 1 ton of lunar soil, you can extract about 0.7 ounces of helium-3. And that amount is enough to run a 10-megawatt fusion reactor for a year. In 2024, Chang'e 6, for the first time in history, delivered soil samples from the far side of the moon. The analysis is still ongoing, but preliminary data shows even higher concentrations of rare elements. The far side turned out to be a real treasure trove of useful minerals. In the samples from Chang'e 6, material from deep inside the moon, brought to the surface by powerful asteroid impacts billions of years ago. There they found elements that are almost non-existent on the surface: iridium, platinum, rare earth metals. These substances are critically important for modern electronics and can cost over $100,000 per ounce. And here it becomes clear why China is rushing to the moon, not to Mars. Mars is a beautiful dream, but it takes more than 9 months to get there, with communication delays of dozens of minutes, and it's impossible to quickly evacuate in case of problems. But the moon is a space outpost just 3 days from Earth, with resources that can change the entire global energy system. Calculations show that delivering 2 pounds of cargo to Mars costs 50 times more than to the moon. At the same time, the useful payload of a Mars mission is 10 times less because of the need to carry fuel for the return trip. And the time to fly to Mars is limited by launch windows, which open only once every 26 months. With the moon, it's the opposite. You can fly at any time. The flight takes 3 days. Communication is almost instant. You can quickly deliver equipment, people, supplies. The moon can become a staging point for deep space flights because launching from it is 20 times easier than from Earth. While the Americans, Europeans, and Russians argue about budgets and dream of Mars, China is methodically carrying out its plan to turn the moon into its own space base. By 2030, the Chinese plan to land their astronauts, called taikonauts, on the moon. And it will not be a symbolic visit, but the start of building a permanent base. For this, a new super heavy rocket called the Long March 10 is already being developed, capable of delivering a crewed spacecraft to the moon. The rocket, 300 feet tall, will be able to put up to 70 tons of payload into low Earth orbit, like the American Saturn V. To the moon, it will be able to send 25 tons of cargo, including a landing module and a crew of 3. The Long March 10 uses environmentally friendly fuel, kerosene and liquid oxygen. The first stage is equipped with 7 engines, each with 500 tons of thrust. The second stage has 2 engines of 200 tons each. The third stage runs on hydrogen and oxygen and can be restarted multiple times in space. Technologies for 3D printing structures from lunar soil are now being developed. Chinese scientists have already learned to make bricks from regolith that are stronger than concrete. A special robot printer can build a dome 35 feet in diameter in just a week, using only lunar materials. Robots are being tested to explore lava tubes. One of the prototypes is a spherical robot 20 inches in diameter, which can roll over rough surfaces and even jump up to 35 feet high. Inside it has radar, cameras, and a navigation system to create 3D maps of the caves. And what are the competitors doing in the meantime? NASA promises to return to the moon by 2026 under the Artemis program, but these dates have already been postponed several times. Initially, it was planned to land in 2024, then moved to 2025. Now they talk about 2026. Problems with the new SLS rocket, with the Orion spacecraft, with the lunar landing module. The Artemis program has already cost American taxpayers $90 billion, but not a single astronaut has been sent to the moon so far. The SLS rocket has flown only twice, both times unmanned. The cost of one launch exceeds $4 billion. Private companies like SpaceX are more focused on Mars. Elon Musk openly says that he is not interested in the moon. It is a boring gray rock without an atmosphere. SpaceX is developing the Starship for flights to Mars, although so far test flights have ended in explosions. Jeff Bezos's Blue Origin plans lunar missions, but so far cannot even reliably launch people on suborbital flights. Virgin Galactic limits itself to space tourism. Europeans and Japanese mostly participate in American projects in secondary roles, and nothing has been heard for a long time about Russian space projects. This creates a paradoxical situation. While the whole world discusses flights to Mars, China quietly takes over the moon. And it's not just national prestige, it's a colossal strategic advantage. Whoever is the first to establish helium-3 mining on the moon will get an almost unlimited source of clean energy. Imagine a country that can produce electricity 100 times cheaper than its competitors. Imagine an industry running on almost free energy. That country will certainly dominate the world economy. Whoever builds bases in lava tubes will be able to use the moon as a spaceport for flights deeper into the solar system. From the lunar surface, you can launch ships to asteroids, to Mars, to the moons of Jupiter. Gravity there is 6 times weaker, so much less fuel is needed. Whoever controls lunar resources will set the rules of the game in space. The moon has not only helium-3, but also water in polar craters, rare metals, titanium for construction. All of this is critically important for space programs. And while other countries waste time on endless discussions and plans, China is already acting. Each Chang'e mission is not just a scientific experiment, but exploration of promising deposits and testing of technologies for future bases. Chinese engineers are already developing robots for detailed exploration of lava tubes from the inside. A prototype called Daedalus is a spherical device 20 inches in diameter, equipped with lidar, cameras, and an autonomous navigation system. It can roll on the surface, climb walls, and even jump in low gravity. They are testing technologies to extract water from lunar ice, because from water you can get oxygen for breathing and hydrogen for rocket fuel. Chinese scientists have developed a compact reactor that can heat lunar soil to 1,100 degrees Fahrenheit and extract water vapor from it with 90% efficiency. They are studying the possibility of smelting metals from lunar ores right on site. Experiments have shown that in vacuum and low-gravity conditions, it is possible to produce ultra-pure alloys that cannot be achieved on Earth. Such materials would be worth over $1 million per pound. China is also creating special jumping robots to explore craters and entrances to lava tubes. In the weak lunar gravity, such devices can move by jumping as high as 330 feet, reaching places that ordinary rovers cannot. One of these robots, the Space Grasshopper, weighs only 26 pounds but can jump over half a mile. On board, it has cameras, spectrometers, and a drill for collecting samples. In a single day, it can survey an area the size of a small city. All this means that in 10 years, China will become the first country with a permanent lunar base, with its own energy and resource sources, and with the ability to launch missions deeper into space without depending on Earth. And the rest of the world will watch as Chinese taikonauts build cities in lava tubes, mine helium-3, and send expeditions to asteroids and planets, using the moon as a refueling station. This is not science fiction. It is the logical continuation of what is happening right now. China is not spreading itself thin over dozens of projects, but is focused on one goal: to make the moon its own. According to Chinese scientists' plans, by 2035, a large international lunar research station will be operating on the moon, but under Chinese leadership and under Chinese rules. Russia was offered very limited participation in it, but Americans and their allies are not provided for in this project. The planned base will be located in one of the lava tubes near the south pole of the moon. There is constant sunlight for energy, water ice in nearby craters, and convenient entrances to underground cavities. The perfect place for a lunar colony. The base will consist of several modules: living, scientific, production, and energy. The living module will be able to house up to 20 people permanently. The scientific one, laboratories for studying the moon and space. The production one, plants for processing lunar resources. The energy one, fusion reactors powered by helium-3. And the most striking thing, all this is happening right before our eyes. But most people don't even realize the scale of what is happening. While we fiercely argue about whether Americans landed on the moon in 1969, the Chinese are planning to live there in just a few years. The Chinese lunar program is not just a space project, it is a geopolitical strategy on a global scale. Beijing is investing tens of billions of dollars in lunar missions, not for science or prestige. They are preparing to reshape the world order. In a few years, we will most likely be buying lunar energy from China, watching as Chinese ships shuttle between Earth and the moon, envying Chinese space technologies that will be decades ahead of everyone else. But the most worrying thing is the legal uncertainty. The 1967 Outer Space Treaty prohibits national appropriation of celestial bodies, but says nothing about mining resources. The Americans in 2015 passed a law allowing private companies to own resources extracted in space. China has not yet officially passed such a law, but in practice acts on the principle of whoever comes first owns it. Imagine the situation. A Chinese base on the moon begins mining helium-3 on an industrial scale. Americans and Europeans demand access to the resources, citing international law. The Chinese reply, "Welcome, build your own bases next to ours." But technologically, China is already decades ahead. Space law experts are already warning about the possibility of lunar wars. Not in the literal sense, no one will shoot on the moon, but economic and technological dominance by one country could lead to serious international conflicts. The Chinese, understanding this, are acting very subtly. They offer international cooperation within the framework of their lunar station, but on their terms. Russia has already agreed. It is expected that Pakistan, Saudi Arabia, and possibly Iran will join the project. This creates an alternative block of space powers under Chinese leadership. And what is happening with the traditional space leaders? The US is trying to build a coalition through the Artemis Accords, but progress is slow. Japan, Canada, and the United Kingdom have signed the accords, but their real contribution to the lunar program is extremely limited. The European Space Agency is torn between participating in the American program and wanting to maintain independence. Some European scientists are already working with Chinese colleagues, bypassing American sanctions. After the escalation of the conflict in Ukraine, Russia has effectively been excluded from Western space projects. Roscosmos is increasingly turning toward China. This means that the Chinese lunar program has gained direct access to Russian expertise in crewed flights and heavy rocketry. But the most important thing, China is already thinking several steps ahead. While everyone else discusses lunar bases, Chinese scientists are planning asteroid missions. From the moon, it is much easier to reach metal-rich asteroids. A single small asteroid could contain platinum worth trillions of dollars, instantly making China the richest country in the world with overwhelming superiority over everyone else. The Chinese Space Agency has already announced serious plans for a mission to an asteroid called 2016 HO3 by 2030. This asteroid is interesting because it moves in an orbit close to Earth's and contains large amounts of rare metals. From a lunar base, such a mission will become a routine operation. There is another aspect that is rarely spoken about openly, the military one. Although the Outer Space Treaty prohibits placing weapons of mass destruction in space, it says nothing about conventional weapons. The country that controls the moon gains enormous strategic advantages. From the moon, it is possible to observe the entire Earth in real time. The Chinese telescope on the far side of the moon is already detecting radio signals that Earth-based observatories cannot pick up. And in the future, from a lunar base, it will be possible to track the movements of all ships, planes, and even cars on Earth. But the main advantage is control over technology. The country that is the first to master fusion power using helium-3 will gain a decisive advantage in all areas. Cheap energy means cheap manufacturing, cheap logistics, cheap computing. Imagine Chinese factories running on energy that is 100 times cheaper than oil and gas. They would be able to produce any goods at prices no one could compete with. This would upend the entire global economy. Chinese supercomputers running on lunar energy would surpass all other systems combined. Chinese artificial intelligence would gain enormous advantages in computing power. And today, AI is the key to dominance in any field. Chinese electric vehicles, airplanes, and ships running on hydrogen from lunar water would become cheaper and more efficient than all competitors. The Chinese space industry would be able to launch satellites and ships dozens of times cheaper than any other country. And all this is starting right now. The Chinese are not waiting like the others. They are acting. Every year brings new achievements, new discoveries, new steps toward dominance in space. In the coming months, the launch of Chang'e 7, a mission to the moon's south pole to search for water ice, will take place. In 2026, Chang'e 8 with testing of base construction technologies. In 2028, the first cargo mission to deliver equipment for the future base. And in 2030, the historic landing of Chinese taikonauts on the moon. But this will not be a repeat of Apollo, not a few days on the surface and then return home. This will be the beginning of China's permanent presence on the moon. The first expedition will stay on the moon for a month in their own lunar base. The second, 3 months. By 2035, the Chinese plan rotating crews who will replace each other every 6 months. By 2040, a permanent base with at least 100 people. The moon has once again become an arena of geopolitical struggle. But unlike the space race of the 1960s, this time it's not about prestige, but about real power over resources that could determine the future of all humanity. In the 1960s, the US and USSR competed for the right to say, "We were first." Today, the Chinese and Americans compete for the right to say, "The moon is ours." And while the Americans argue about budgets and delay deadlines, the Chinese are methodically turning it into reality. Perhaps in 20 years, school children will study these years as the moment when the fate of humanity in space was decided. The moment when one country made the right bet on the planet closest to us, while the others dreamed of distant worlds. History shows Whoever controls key resources sets the rules of the game. In the past, it was spices, then oil, then the internet. Tomorrow it will be helium-3 from the moon. And everything points to the fact that it is China that will be the first to access this source of unlimited energy. And from the far side of the moon, hidden from our eyes, the fate of all earthly civilization will be controlled.